This type of gain stage can be very useful, but it's not without its problems. One of them being this bias network here that's necessary to bias the transistor properly has a low input impedance. This could be real problematic if you're trying to amplify like a high impedance microphone or something, or another stage previous that is also high impedance. You'll be wasting gain like crazy. So one way around that is to bootstrap the input, or what they call bootstrapping, which is basically where you isolate this bias network off with another resistor, so the signal will appear across that resistor first. Then, using positive feedback, you take a signal off the emitter and couple it to the other end of that resistor. And what ends up happening is that the input is not directly connected to the bias network, and the voltage across this resistor is very, very small. So the current through it is going to be very small because the voltage is the same on both sides, or almost the same. And that's dependent on the gain of an emitter follower in this configuration. And you'll see why that is in a moment. But basically, if this value were 1, the input impedance would be infinite. But it's not 1, but it will still make the impedance very high. And in this case, it'll be like 170k as opposed to like 11k, which is really good. But it's only going to be at signal frequencies, because this cap here won't work down to DC, but it'll work down to whatever, this roll-off is. So the reason why this isn't infinite is because of this. Got to the intrinsic emitter resistance again, kicking our asses here. And it creates a voltage divider between the physical RE and this the 10 mic cap here. And what ends up happening is you only see 0.975 of the voltage you should be seeing at the end of this cap, which is why you have this in an emitter follower. It's because of this potential divider. Now I have a circuit here, which on the left we have the standard gain stage, and on the right we have the bootstrapped gain stage. And on the scope, this is the standard gain stage here. Well, actually, I'm driving it with a 900 hertz sine wave, 10 volt rails, and I have a 10k resistor here between the supply and this cap here. So you'll see the loading effects. The whole point of this is to demonstrate the loading effects of this and this. There's a difference. Now, we're getting a gain of about 10. That small waveform is the input, and the large waveform is the output. And channel 1 is the low input. It's about 0.2 peak to peak, and the output's about 2 volt peak to peak. So it's a gain of 10. Now, if I move this over now to, so that's the output. You will see that the input is larger now, and so is this corresponding output, of course. So there's not near as much loading going on, because 10k is not near significant at this 170k input impedance as it would be at 11k. At 11k, I mean, you're probably dropping like half your signal. So this can be used to also increase the gain of an amplifier. And that can be done using it's using the same exact principle, but it's a little different looking circuit here. So basically you've got your gain stage, but you've broken up that 10k load into 2 resistors. You've got the 8.2k and then your 1.8K. This is going to be your bootstrap resistor. You're directly coupling an emitter follower, and you're taking that input and feeding it back. So the exact same thing is going on here, and it boosts the gain tremendously, because that resistor is now going to look gigantic at signal frequencies. And so its impedance, because it's only at signal frequencies, is going to go up to 72K. It's going to look like a 72K. And we're using 0.975 as our gain, as our emitter follower gain. And so added together with that 8.2K, it looks like an 80.2K resistor at signal frequencies. So our gain is going to go from 10 to 80.2. Yeah, now I got to change all these inputs around here, all these connections. So that's got to go there. Okay, so let me adjust the scope because... Alright, so that's the input. As you can see, it's clipping hard right now because... Bring that down, okay. So now you have... Oh, geez. Yeah, so now you have about a 40 millivolt peak-to-peak input, and then what is that? That's like a... That's a gigantic output. I think I calculated the gain to be about 87. And as you can see, there's a bit of distortion there. It's not perfect. Let me bring that up just a bit more. Yeah, see, a little bit of second harmonic because it's asymmetric. You got a little bit of rounding at the bottom here. Yeah, soft clipping. That's interesting. But yeah, that's typical of a stage like this. When you have that much gain in a single stage, it doesn't come without a price, and that price is distortion. But this bootstrapping technique is used everywhere to boost gain and to boost input impedances. Hope you found this helpful.